we have to carry on with the work. We did in the previous period, we had a look at the making of salts. All right? 3 methods. The one is a soluble acid and a base. The next one was an acid plus an insoluble base. And the third method was using 2 insoluble salts. 2 soluble salts. We add them together, it makes an insoluble salt. Okay, now I don't want to say more about that. The next section that we must have a look at then has got to do with the identification of the different ions. Now, we divided up into different sections. The first section is the positive ions. What's another word for a positive ion? Is the cat or an anion? It's a cat ion. It's an anion. Okay, an anion is attracted to the anode, and the anode is positive. No, it's a cation. Seriously. Okay. The what? Yeah. Okay, and when you get a cathode, there's also a T, but a cathode is negative. Okay, people, in general, the cations are the metal ions. Okay. Now, we are going to have a look then at it's actually got to do with the colors of these ions when we sort of force them to form insoluble salts or solutions. Now, in your textbooks on page 86, there's a very important part, and you tend to not read it. All right? So right at the bottom of page 86, there's a heading, the chemistry behind the tests, and then dash cations. I want to read the section. They say, when you carry out the test for the cations, okay, the cations are the metal ions mostly. Ammonium is also a cation. Okay. You will make the metal hydroxide. Why? Most metal hydroxides are insoluble. All right. And those of transition metals are colored. All right. So the color of the precipitate would therefore tell us which metal we have. Right, now on the next page, there is a table of the different metal ions that we must be able to test for. Now, on page 87, we have got aluminium, we've got calcium, and we've got zinc, and there's a reason why I write them like that next to each other. Then we will test for copper and iron. Copper 2+, aluminium is 3+, calcium is 2+, zinc is 2+. We are going to test for copper 2+ ions. We are going to test for copper 2 and for copper 3. Ions, ione. Iron 2 and iron 3. All right. When we test for metal ions, that sentence that we've just read, we need to make a hydroxide because most of the hydroxides are insoluble. So how will I make a hydroxide? We've just done making of salts. We add 2 soluble salts together and we can make an insoluble salt. Okay, so I must add something to this. For example, if I have copper chloride in solution, to the copper chloride, I can add sodium hydroxide. These are 2 soluble salts, and I will get copper hydroxide, which is insoluble. Do you understand? All right. Now, the same thing happens with all of the metal ions. So, the first reagent that I use to test for my metal ions would be to add a few drops of sodium hydroxide. There's a reason why it's a few drops. Okay. We find that sometimes, not with all of them, if I add a few drops, it immediately makes an insoluble salt. The insoluble salt you can see because it becomes milky. You can't see through the solution anymore. And if you left it to stand overnight, the next morning, there will be a powder in the bottom of the test tube that you can filter out. Okay? That's not white. Copper is blue. It's not necessarily white. There is a powder left. Yes, a solid is formed. Well, that is the precipitate. That's the insoluble salt. The hydroxide. The metal hydroxide. Okay? Different metals have different colors. But this stuff then is the precipitate. And the color of that precipitate indicates what metal I have. Oh. When you add a few drops of sodium hydroxide, we make the insoluble salt. Now, when you add excess, what does excess mean? Lots of it. Okay, I will fill up the test tube with it. Then we sometimes find, not by all of them, but that something special happens, and what is formed is called a complex ion, which is soluble. In other words, then this precipitate suddenly disappears. Okay, but I'll come back to the complex ions that are formed a little bit later on. If I add sodium hydroxide to a solution containing copper ions, I will get a copper hydroxide precipitate. And it's blue in color, light blue. Okay, so what's the color of copper sulfate? Blue. All right, it's a similar color blue that we are talking about, light blue. If I add a couple of drops of sodium hydroxide to iron 2, I will get iron, come on. All right, copper hydroxide, I will get an iron hydroxide, which is green in color. All right? And if I have got iron 3 ions in solution, and I add sodium hydroxide to it, I will get a red precipitate. Yeah, a red-brown. Okay? What's the color of rust? Rust is iron 3. Yes. But it's the iron 3 plus iron. Whether it's the oxide or the hydroxide, the iron 3 plus iron is red, reddish brown. Well, yes. If the oxide that is formed is green, then it's iron 2 oxide that has formed. Yes, 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 yes. But that could be a deposition of other salts as well. Okay. But in general, iron 2 is green, iron 3 is red. Now, how are you going to remember that? Well, iron 2 is green, and green has got 2 E's. Yeah. Iron 3 is red, and red has got 3 letters, so don't confuse it. Okay, those are the only 3 colors that you must remember for the metal salts. Copper is blue, iron 2 is green, and iron 3 is red. The others over here will form aluminium hydroxide, calcium hydroxide, and zinc hydroxide, and they, unfortunately, are all white. No. Okay, now, so if you get a white salt, then you can know it's either aluminium, calcium, or zinc. You with me? So there's a second step. Okay, just have a look. Go to your notes, your textbooks. They start off at the top of page 87. For aluminium, add 2 drops of sodium hydroxide, a white precipitate will form. For zinc, add 2 drops of sodium hydroxide, a white precipitate will form. For calcium, 2 drops of sodium, a white precipitate will form. Are you with me? Now, the second step, we now go and add excess sodium hydroxide. We find that A to Z will disappear in excess. Calcium will remain. So, I've got my test tube. I've put a few drops of sodium hydroxide into it. I get a white precipitate. I must immediately know I've either got aluminium, calcium, or zinc. So now the second step is to add excess sodium hydroxide. So I fill up the test tube. If the precipitate remains, we've got calcium. If the precipitate disappears, it becomes soluble. We've got either aluminium or zinc. All right. Now, I'll come back to distinguishing between aluminium and zinc. We have got aluminium, calcium, zinc. Then we've got copper, we've got iron, and we've got iron. All right. Now, the first set of tests, we used what as a reagent? Sodium hydroxide. Now, there's a second set of tests that we can use. The reagent that we will use is ammonia solution. Now, ammonia solution, ammonia, if I dissolve it in water, it forms ammonium hydroxide. So the reagent that we are going to be testing with is actually ammonium hydroxide. It's a hydroxide. Okay, so if I add a couple of drops of ammonium hydroxide, what will I get by copper? A light blue precipitate. What will I get with iron 2? A green precipitate. What will I get with iron 3? A red precipitate. And what will I get over here? A white precipitate. Okay, go back to your notes. I'm busy with aluminium, zinc, and calcium. They say by zinc, by calcium and aluminium, they only refer to sodium hydroxide. All right? But it will form a white precipitate with ammonium hydroxide, a few drops. If you go and read by zinc, they say add 2 drops of ammonium hydroxide, you will get a white precipitate. And when you add excess ammonium hydroxide, what's going to happen? The zinc is soluble. This one is soluble in excess ammonium hydroxide. All right. Remember with the first test, aluminium and zinc dissolves. Calcium remains. So we've sorted calcium from that equation. So if I have a test tube and I don't know whether it's aluminium or zinc, what am I going to use? Ammonium hydroxide, because aluminium is going to make a white precipitate that is going to stay. And zinc is going to make a precipitate that's going to disappear. Yeah. Yes. 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 Then you know you've got calcium. Yes. No, you must make a fresh solution. You start off with a fresh iron solution. Yes. Well, you will set up 2 test tubes with aluminium, 2 with zinc, 2 with calcium. So in the first set of test tubes, you add the sodium hydroxide. You get the white precipitate. Disappears or doesn't disappear. You want to confirm. You use the second set of test tubes. Do you understand? And you start with ammonium hydroxide. Okay? No, no. You must start with a fresh solution in a new test tube. No, not always, because then the zinc is going to be... It just forms a white precipitate. It doesn't disappear. Slightly all white. In actual fact, the calcium forms a slight all white precipitate. It's not at all. You have to do both steps if you want to sort out those three. Okay. Okay, now, when we're going to have a look at the metal ions with ammonium hydroxide, we said we get the light blue precipitate, we get the green precipitate, and we get the red precipitate. Here by copper, there's something extra that happens. If I go and add excess to all of them, the green precipitate will remain, the red precipitate will remain. But the light blue precipitate of copper, if I add excess ammonium hydroxide, it forms the ammoniated complex ion, which is a deep dark blue solution. All right. That's the color of your shirt. That is the metal ions. Okay. Now I'm going to stop there because I've got a video clip somewhere that I will show you. Okay. All right, grade 11s. We had a look yesterday at the test for metals, metal ions, the cat ions, okay? And the reagents that we used to test the metal ions were, first of all, sodium hydroxide, and then there was a second set of tests that we used ammonium hydroxide. And in each case, we found that we got a precipitate or no precipitate, okay? The first metals that we had a look at was aluminium, calcium, zinc. Then we had copper, iron, 3 plus 2 plus 2 plus 2 plus 2 plus 3 plus. All right. We found that with sodium hydroxide, with these three, if you add a few drops, we got a white precipitate. On adding excess, we said calcium persists, but aluminium and zinc becomes soluble. All right. We said copper gives a light blue precipitate. Iron 2, we said gives a green precipitate, and iron 3 gives us a red, precipitate, or in brackets solid. Yeah. Okay. Sometimes they use this like that. All right. Then we said there's a second set of tests that we can do because this test does not distinguish between aluminium and zinc. Okay. So to distinguish between aluminium and zinc, we will get a white precipitate. On excess, which one dissolves? Okay. Then with the rest, We got a light blue precipitate, a green precipitate, and a red precipitate. Although here by the copper, on adding excess, what did we get? Dark blue solution. All right, in other words, the precipitate becomes soluble. Now, people, you need to know these tests, okay? There's no way around this. On paper 3 for the ordinary level, they give you a table with this information. Higher level, when you do practical and you need to do testing for ions, they give you the chart with the tests on it. But for paper 1 and paper 2, you need to know these tests. And they do ask the questions. All right? Yeah. Because paper 3, the alternative to practical and practical, does not test root learning work. It tests a different skill. Okay? So you need to know this. You have to go and learn this. Okay, now. Yeah. Okay. The next thing that we have to have a look at is the anions. Now, the anions are negative ions, and the ones that we must have a look at is carbonate and sulfate and iodide and nitrate. Is there chloride as well? Yes, chloride as well. Let's do it over there. Okay. Please, people, take note the difference between chloride and chlorine. There's a difference. The one is the ion. It's usually soluble. The other one is the element, which is often not soluble in water. The chloride is the ion, yes. All right. The chlorine is the diatomic element. So we are testing for the ions. All right. Now I'm going to start off with the carbonate. Yeah. Yes. Yeah, usually the non-metal ions, yes. No, there isn't an exception. All right. People, test for carbonate is actually sort of indirect. We know that if we take an acid plus a carbonate, we will get a salt plus water plus carbon dioxide. How do we test for carbon dioxide? Bubble the gas through clear lime water. If the water turns milky, it is carbon dioxide. So, how do we test for carbonates? Well, we will add an acid to the carbonate. And it's going to fizz. It's going to bubble. There's going to be effervescence. So the moment you see that, you have to catch up the gas. And you have to test the gas to see whether it will turn clear lime water milky. Will you bother testing it with a splint? No. Because some gases will make a splint die. Others, like hydrogen, can also make it pop. Okay, it depends a little bit. So we are going to specifically test to see, is there carbon dioxide? Because if there is, then we've got a carbonate. If there isn't, we didn't have a carbonate. Do you understand? It is slightly more dense than air. Okay. When I catch up the carbon dioxide, this is very important. If I want to catch up hydrogen, you've seen the diagram. We go and bubble the gas. We've got water here, okay? And as the gas bubbles up, are you with me? It pushes the water down. We talk about the downwards displacement of water. Can I catch up carbon dioxide with a downwards displacement of water? It's water soluble. So I would catch up carbon dioxide. It's just much easier. I'd take a cylinder and I'd put the gas in there, and the carbon dioxide will go to the top, and what is going to be pushed out? Air. The upwards displacement of air can be used to catch up carbon dioxide. Yes, yes. Or you can just simply, on the container, and this is usually how we do it, you'll do it in a conical flask. You'll put a stopper in it, all right, with a tube, and it will deliver it directly into clear lime water. You'll bubble it through. If it becomes milky, we've got a carbonate. Because it's hot due to burning, combustion. Hot gases rise. Yes, but then it gets trapped due to temperature inversion in a layer in the air. Okay? Yeah. That's why it causes a problem. It shouldn't be there. Or not as much of it should be there. A little bit must be there because it's the greenhouse effect that keeps the temperatures moderate, but it's becoming too much. Okay, so the test for carbonate. Add an acid, test the gas with clear lime water. If it turns milky, we've got a carbonate. So in your textbooks, they've got the add dilute acid, test the gas evolved with lime water. The result, lime water turns milky. Okay, now, to test for a sulfate, you will see with many of these tests, they add a couple of drops of nitric acid. The reason for this is that's for the test for the chlorides and the iodides as well. All nitrates are soluble. So sometimes if there is an impurity, the nitric acid that you've added will keep the impurities, the tiny amounts, out of the test so it doesn't confuse the test. So very often the test starts with acidify with a couple of drops of nitric acid. No, because it's going to fizz. Okay. Then to test for a sulfate, we will add barium chloride or barium nitrate will also work. Okay, barium chloride, a soluble barium salt. Okay, because what happens is most of my sulfates that you will work with are water soluble. And the moment the barium is added, we make barium sulfate, which is a white precipitate. So the moment you must test for sulfate, it doesn't matter what sulfate you are testing for, calcium sulfate, hydrogen sulfate, sodium sulfate, aluminium sulfate, it doesn't matter. The moment you test for sulfate, the SO4 ion, you add barium ions to it, a soluble barium. Because the barium sulfate that is formed is insoluble. And it's a white precipitate. And it's very clear, it's not obscure. All right. All right. In your textbooks, they say add 2 drops of hydrochloric acid, dilute hydrochloric acid, followed by 2 drops of barium chloride. You will get a white precipitate. Yeah, it doesn't really matter. Okay. Then, the chloride and the iodide. For the chloride, they say add 2 drops of dilute nitric acid. For the iodide, add 2 drops of dilute nitric acid. Actually, chloride, bromide, and iodide add 2 drops of dilute nitric acid. Then the next reagent that they add is silver nitrate. So for chlorides and iodides, I will add silver nitrate. Now, silver nitrate is a colorless liquid. It looks like water. All right. What you will get is all chlorides, bromides, iodides are soluble except those of silver, lead, and mercury. So we are going to produce, over here, this reaction is going to produce silver iodide. Yes, although sometimes there's complications to the reaction, which could be similar to something else that we can test for. So this is why we work with silver. Okay, yes. Just add a little bit, a couple of drops of dilute acid. All right. A little bit of impurities, sometimes the reaction just occurs better in an acid medium. But that's not important. What is very important is you add silver nitrate. Now, if you add silver nitrate to the chloride ion, you are going to get over here silver chloride. All right. Now, if you had the bromide ion, ek gaan nou vir julle hulle kleure sê. Okay. If we had the bromide ion over here, I would also add silver nitrate, and I will get silver bromide, also in the form of a precipitate. Now, these precipitates are very clear. It forms a cloudy mixture. All right. The color. Silver chloride is white, silver bromide is cream, and silver iodide is yellow. Hang on. If I asked you, what's the color of this wall? Okay. The problem with these three tests, the white, you can probably guess and say it's white. But the cream and the yellow are so close together that it's very difficult to distinguish. Okay? Yeah, we've already done that. Yes, that's it. And that is why we have the other test that we did, no? Okay. Where we add the ammonia to see whether the precipitate dissolves or does not. Dilute concentrated and not at all. No? Do you understand? Kyk hoe lyk julle. Oh my word. People, we've done it previously when we did periodic table. We said the silver chloride, the silver bromide, and the silver iodide. Once you get that precipitate, we go and add dilute ammonia. Then we add concentrated ammonia, and we will find the chloride dissolves in dilute ammonia, the bromide dissolves in concentrated ammonia, and the iodide does not dissolve. Are you with me? Okay, so that work connects up with this work. So if we go and have a look there in your books on the table that they give you, they say for the chloride, you acidify with nitric acid followed by silver nitrate, we get a white precipitate. The iodide, adding silver nitrate, we will get a yellow precipitate, and then they say, confirm by adding 2 drops of lead nitrate. Lead nitrate is going to form lead iodide, which is a bright yellow substance. All right. So there are basically, well, not for all of them, but 2 sets of tests. Okay. Chloride, bromide, iodide, we test with silver nitrate. To distinguish between the 3 of them, we can add dilute ammonia, concentrated ammonia, or, yeah, and if it disappears or doesn't disappear, we know which one we have. Or, the confirmation test of iodine is to add a little bit of lead nitrate. And if you get a bright yellow, it's the yellow paint yellow is the color of the stuff. All right. You get lead iodide, which is yellow. And the difference between the yellow precipitates, the original, this one, is very light, almost white, creamy yellow. The lead iodide that you add to it, lead nitrate that you add to it, forms lead iodide, and that lead iodide is yellow, like in bright yellow. Okay. Yeah. On my pen. All right there. Okay. That is the test for the anions. The last one we have to do is the test for nitrates. Now I'm going to carry on to the next page. Now I'm out of my pen, and I don't want to be out of my pen. Seriously. Pen. Oh, come on. There, pen, and there. Oh, seriously. Okay, it doesn't matter. Maybe. Yes, how did you know that? Okay, good. All right. The last test is the test for nitrates. Now, this one is slightly more complicated. Now, nitrate is NO3, and it's got a valency of 1. Now, to test for nitrates, we have to not add an acid, but we add in the first place a little bit of aluminium. Now, in your books, they talk about aluminium filings. A piece of aluminium foil, tin foil, works very well. You just tear off a little piece and you put it into the container. Then you don't add an acid, you add sodium hydroxide. So first of all, we add a little bit of aluminium, a strip of aluminium. Then we will go and use a base, sodium hydroxide. Then you will very gently heat this. And a gas will be given off, which, if it is a nitrate, the gas that would be produced with this would be ammonia. And how do we test for ammonia? Acid or a base? A base. How do I test acids and bases? Yes, damp red litmus paper will turn blue. Yeah, it must be a watery medium to dissolve. No. No. These tests are very specific. Okay. All right. That is the test for the anions. Now, lastly, and they don't have it listed there, we have to test for gases, but most of the gases we've done already. How do I test for hydrogen gas? Not a glowing, a burning splint. Makes a popping or whistling sound. How do I test for oxygen? A glowing splint will relight. How do I test for carbon dioxide? Bubble it through clear lime water. Yeah, and it will turn milky. What's the other gas? Okay. We've just done ammonia. How do I test for ammonia? Red litmus will turn blue. Well, this reaction won't give off any base. It will give off specifically ammonia. All right. No. Damp red litmus will turn blue. Now, the last gas that we have to test for is chlorine gas. Not chloride ions, but chlorine gas. Yes, chlorine is slightly green, light green in color. Okay. I would prefer not to breathe in chlorine. It's going to dissolve in the water in your lungs, and it's going to form an acid, and you will cough, and it could damage your lungs. All right. Chlorine gas is used to sterilize water. It oxidizes germs. Okay. Now, how do I test for chlorine gas? Well, there's a reason why I did it after I did the ammonia test. For ammonia, we find that it changes red litmus blue. But chlorine, if I mess Jik and Domestos on my clothes, what happens to it? It bleaches because it contains chlorine. So chlorine will bleach. Damp litmus. Whichever, whether you had red litmus or blue litmus, it wouldn't matter. It's going to make it go white. Wet. Yes. Because there must be a watery medium in which the reaction can occur. Yes. Yeah. Nope. Okay.
It's Shoprite's big low price birthday. We're celebrating with big deals and even bigger savings. Like a bottle of Stay Soft fabric softener, only $32.99. And a tin of Ricoffee, just $78.99. Don't miss out on our big low price birthday. Only at Shoprite.
You can be tempted to become bitter and cynical. You're tempted. You're not there yet. Maar jy het besluit, man, die ding wat ek aangedoen is, gaan my verbitter, ek gaan my verbitter maak. So you feel to give yourself over to those emotions of becoming cynical and you can also be tempted to take revenge. Paulus sê, you have been grafted, julle is ingeënt in Christus. Wat Christus is, moet julle wees. Wat uit hierdie boom uitkom, ek is die ware wynstok, ek is eintlik die bron waaruit julle lewe. Dit moet in julle vrug wees. Julle moet smaak soos ek smaak, sê die Here. Kan ek 'n amen kry? Ek hou niks meer van julle terug nie.
I am a busy night. I am a busy night.
I like rhinos. I like them very much. Future here in this area is depending on the tourism. The future generation, they can see and they can benefit from their own resources. Animals like rhinos, elephants, the big five, you benefit from them and it must be respected. You are not feeding the rhinos, you are not giving them order, so it's a free business. I take two of my sons, which was little bit 5 years old. They were young guys. So they asked me questions. Why are we here? Why are we sleeping here? I told them this is our resources and this is our future. My first memory of going with my dad is that I learned new things. As I grow up as a man, I see an opportunity in it. So I decided to look for a job pertaining to tourism. So that's when I was employed at Palembang. So I decided to go for tour guide studies, because I grew up with the tourism industry, the wildlife, the rhinos and everything, to bring that experience to the tourists. You can see the hyena. The biggest change is I was employed, getting paid, and also I can now support my family.
It's a cultural thing. It's coming a long way. Even if you go to area like Tweefontein, area was a lot of paintings. You will see rhino engravings on the rocks. That is an indication that the interaction between human, especially the local communities, and wildlife is dating back. That intimacy relationship is coming for a long time.
We are right here now at Palembang, and Palembang is one of the big lodges in the heart of the desert. And as you can see there is Jumbo standing behind me, which shows it's really a tourist area. We do have elephants, lions, but as you can see, the desert is the heart of the rhinos. This is the main breeding area of the rhinos, is what we found here in this desert.
It's the largest free-roaming population of black rhinos that you find outside national parks in the world. It's a population that communities in the northwest have taken responsibility themselves in managing this population with the structures that government has put in place, more specifically the establishment of conservancies.
These people, before independence, they took it upon themselves and decided that wildlife is our heritage, and through history we've been living with wildlife. And having wildlife in your area is like having a garden.
Because of all these animals, we've got the communities that benefit from all this wildlife, and it's like a triangle that fits into each other. And the communities looked after the wildlife doing their own thing, and the communities benefit.
So already there were this intergenerational relationship between mankind and wildlife, and that bond is what our people actually wanted to see it continuing.
Very few countries have the wildlife that Namibia has. What is also important is the policies that Namibia has put in place, which also involves communities to be engaged in the management of the wildlife species and also to benefit from the wildlife resources.
Turn conservation into a rural economy, turn conservation into endless opportunities that would actually cater for those young people that have nothing else to do.
If it was not for rhino economy and tourism in this area, it was really difficult for young people to get or find a job.
We are conservation engineers. We make conservation work in an unfenced area, and through that, we want to turn the wildlife into the rural economy that will benefit the rural communities.
So we can see now wildlife is doing very well, the lodges are doing well, and the community is also benefiting. So it takes all three together.
Devastating hit over coronavirus fears. Airline industry is facing its biggest threat to travel since 9/11.
Since March, when COVID-19 hit Namibia, things actually become very difficult. In the first place, all the lodges closed down because of COVID-19. With us, say the Rhino Trust, we had some donors cutting on their funding. And then we had, in the same time, a poaching case of 2 rhinos that was poached. We had less boots on the ground, and poachers could actually see. Now it's our chance to go in and do something. So COVID-19 was tough on all of us. Ginger Morning, who is one of our trustees, actually came up with the idea of, why don't we ask you to go to buy some gold for us and make gold bars, and then we sell them for rhino conservation.
I was fortunate enough to have a chance to have lunch with Clive Johnson, the CEO of B2 Gold in Vancouver, Canada. And I looked at Clive and I said, you know, we've got rhinos, you've got gold, let's do something. Let's create a coin or a medallion or a bar using your resource to create a sustainable source of funding for rhino conservation for the future.
There was it. The gold was bought, the bar was made, and I think it was January, 31st of January that we launched the bars in Windhoek. And suddenly one morning I had an email from my office, from my finance person saying, these people don't have salaries. So I said, oh, what now? So I picked up my phone and I phoned Mark Daw. I said, Mark, I've got this problem. He said, but when we've got the fund already ready for you, you just have to apply, put a proposal in.
1,000 ounces of gold can make an enormous difference to the livelihoods of the communities that live up there. We are, in essence, providing income and providing a livelihood to the communities. In the absence of tourism, especially now with COVID-19, even prior to that, when we had such a bad drought, the communities became even more dependent on the natural economy.
The idea is to make this a fund that will last for the next 25, 30 years, or even longer. And a portion of that will be distributed immediately as needed. And in this case, the COVID-19 crisis necessitated us to distribute funds to pay salaries to help people in the field.
The proceeds of the sales from the gold bars will be going towards responsible NGOs. And we've identified Save the Rhino Trust as the key NGO. And IRDNC, one of the first organizations that was in the Northwest, Integrated Rural Development and Nature Conservation, so that ultimately the funds go to the communities and various aspects of their war on poaching.
To be able to support those hardworking men and women that are always in the front line between the poachers and the rhinos.
If it was not for B2 Gold and the golden bars, I think by now we should have been in big trouble.
By extracting the gold, you reinvest it in other renewable resources.
The gold that's coming out from the ground is actually protecting the wildlife that's working on the ground, which is a very good symbol for the others.
I wish this was my bar. This is the 500 gram gold bar. So you'll see on this side you've got the Etindeka Mountains and you've got the mother rhino with her calf. And then on the reverse side, we've got the serial number, you've got the Rand refinery stamp, which is very important. Anywhere in the world, people will recognize the stamp and they will know that this bar contains 99.99% gold.
It is gorgeous.
We wanted to make a biggest contribution. And at Ballowwood, we see that as a way of giving back to the community.
Okay, so there you'll see the 500 gram bar.
Very special.
Feel the weight. It's incredible.
This opportunity which presented itself is absolutely a once-in-a-lifetime opportunity.
We're privileged to have this.
This is just absolutely gorgeous, and I think this showcase really what the project is all about.
It's from 24 karat Namibian gold.
I'm looking at these rhinos is put there like Miss World photogenic, I would say.
There are only 1,000 of these gold bars, rhino gold bars, in circulation.
As far as I'm aware, it's the largest single donation of any corporate to the conservation of biodiversity anywhere in Africa.
Therefore, we so much appreciate and would want to continue as a government to work with B2 Gold.
And the fact that it's happening here in Namibia is something that we can all be extremely proud about and very grateful to B2 Gold.
Thanks to having this literal pot of gold through the funding for the Rhino Gold Bar, we're able to step in now and make sure that those trackers are supported, and so are their families and their communities.
We make sure that people sustain their jobs going forward, and who doesn't want gold?
And the B2 Gold Rhino Gold Bar has come in at a really critical time now, particularly with tourism being closed off and those forms of revenue not coming in.
To say we have the biggest rhino population or black rhino population in the world, let it be for the rest of our lives. And it's that heritage that we have It's our resource that we can all look after and protect.
It's our heritage. And it's also good that other people like Peter Gold are also seeing it that way.
It's actually a very nice link between the investor that buys this gold bar, the rhino tracker in the northwest of Namibia, and the black rhinos. It's an intergenerational thing. The rhino trackers teach their children how to track rhinos, their children get taught, and so it flows down.
This is something that I want my children to have, and that we leave a little bit of a B2 Gold legacy. And if I can be part of that as part of my family, I'd be very proud.
It can also become an inheritance for the generations of my own clan. My children, my grandchildren.
If we can bring that passion over to future generations and to hand that over to my children, and I hope that that same passion for conservation gets migrated over to my kids.
And what we've done together is create a sustainable source of funding that should outlive all of us.
You know, I think as far as B2 Gold is concerned, we couldn't have chosen a better target in which to put our efforts as far as the environmental and conservation pillar is concerned. And I want to stress there that the money that's going towards environment and conservation is actually going towards the people.
Rhino is for all of us, whether you are in Canada, whether you are in Vancouver, whether you are in the US. If you really want to see conservation at play with rural communities, I therefore humbly request each and everyone to join us on our Rhino tour and have a wonderful experience. This is what keeps rhinos on this planet.
I've done rhino trekking experience. It was just amazing walking in that landscape of the Kunene. And as we followed them, we could now find rhinos with the calf. We got the closest distance we could.
It's a warning sign.
And it was just amazing and lovely. It's something to experience that Namibia can offer. It's something that you have to do in your life.
Sy het nog steeds abandonment issues.
Is moontlik.
Ons moeite met die sprokies. Ek probeer so hard om my kind gelukkig te maak, maar ek kry dit nie reg nie.
Probeer net help, dis al.
Jy doen niks sonder bymotiewe nie.
So jy hou van die tattoo?
Nee. Maar jy kan nie liefde koop nie. En beslis nie myne nie.
Jy regular.
Am I that predictable?
Jy is 'n gereelde klant en ons net so 'n manier om koffie te drink.
How do you like your coffee?
Gewoonlik swart sonder suiker.
Does black and bitter only pertain to your coffee preference?
Ek hou maar net van my koffie sonder melk. Hoe gaan dit op bal raak slaan na 2 glase wyn?
That was part of my plan.
Wat? Om 'n tipsie te maak sodat jy kan wen.
I'm terrible at pata.